Assalamualaikum and very good morning to everyone. My name is Nurana Maisra Marintinordin with metric number AE210028. So today I'm going to show you how I'm going to draw the 2S2P permanent magnet synchronized motor by using GMAG Designer. So the first thing I'm going to show you is to design the rotor. So to design the rotor, I'm going to take a circle with the radius 5mm known as the shaft, and then I'm going to take another circle with the radius 20.5 milliliter. So then we're gonna make line at the x-axis and y-axis, and then we make another line through the x-axis, and then the distance between the first line and the second line is 5 milliliter. So then we are gonna trim our rotor. The circle, we take out all the unnecessary things, and don't forget to trim at here. Then we're gonna make another circle with the radius of 14 milliliter. Then we press the OK button, and we're gonna trim again. We delete the unnecessary lines and curve. So here is the result of our quarter rotor. So next, what we are gonna do is we are duplicate it to make a full rotor. So what you need to do is just click right of the mouse and try to find the geometry, create geometry, and then you technically press the merge and then OK. And here is our half design of our rotor. Next, we are going to do the same thing at the y-axis. So here is our full rotor. So next, we're going to design the permanent magnet at the both side of the rotor. So the first thing first is we need to design this. We need to make a circle with the radius 20.5 milliliter, and then we'll make another one with the radius 24 milliliter. And we're gonna make two lines at the x-axis. The difference between first line and the second line at the x-axis is 5 milliliter. So here you go. Then we're gonna make another line at the y-axis. Then we're gonna trim our permanent magnet, delete unnecessary line and curve, and most importantly at the shaft part, we need to make sure there is no line at there. So next, we're gonna duplicate it and make it at the y-axis at the right side of the rotor. And here is our permanent magnet, and duplicate it and make it at the left side of the rotor. So here is our permanent magnet. So the next part is I'm going to design the stator. So to design stator, I'm going to start with make it a circle with radius 24.5 milliliter. So next, I'm going to make another two circle with radius 45 milliliter and 40 milliliter. So this is how it's so after that, we're gonna do the same thing at the x-axis and y-axis. So basically, we need two lines at the y-axis. The distance between two lines is 5 milliliter. After that, we're gonna trim the unnecessary line. We take it out, and then we're gonna make another line at the y-axis, and we trim it again and delete unnecessary curve. After that, we're gonna duplicate it and make it all over our rotor, and then we duplicate and make it at the y-axis, and then do the same thing at the left side of the rotor. So this is how our stator looks like. So the last part is I'm going to design the armature coil. So basically, we're gonna start it with two circles which have the radius 24.5 and 40 milliliter. So next, we're going to make the same line at the y-axis and x-axis, and then after that, we're going to trim it. And don't forget to make another line at the x-axis, which is the distance between the origin is 5 milliliter, and then trim it again. And this is our armature coil looks like, and then we're gonna make it all over the rotor. And this is how our cross-section view of 2S2 PPMSM looks like. So that's all for me. Thank you.
Hello, my name is Yaki Sandiran and my matrix ID is DE220168. So today I would like to show my simulation regarding the JMAC designer which is stated in the lab sheet, which is the activity 2. So first and foremost, as you all know, this middle part that is being highlighted now is the rotor, and then there's two permanent magnets, one stator which is stationary and the rotor which is will rotate, and four armature coils. So I would like to start off by saying the first steps, explaining the first step of the particular process, activity 2. So first and foremost, we have to assign the particular compartments to a particular material. So for instance, rotor must be assigned to a material which is called 35H210, a magnetic material, which is, okay, so this. So we drag it here and put. Same thing goes for the permanent magnet, which I use, which is Neomax P9. So when you just search it out, it comes here, invisible here. So you just drag it and drop it at the permanent magnet. So that's how you do it. Following up with the stator and rotor use the same material, and also the armature coil. There's two types of conductors. Which is okay. We are supposed to use copper, so there's four armature coils here. So you have to drag it one here, one here, one here, one here. So there's four. You have to do it 4 times. So following up with the next steps, where you have to assign to the assign parts with the particular conditions. Like for instance, uh, the rotor which is going to rotate. You got to put the rotation motion for the rotor and also the permanent magnets, because it's going to be rotating along with the rotor. And then a torque is here. Torque nodal force, which was stated in the lab sheet. You can check it out there. So you can drag it out here and also put for the stator and along with the permanent magnets. So following up with the FEM coil, so you can just see the outwards and inwards of the coil. So how did I do this? First and foremost, I have created a circuit. So this is the circuit. The circuit consists of two coils and the ground. Okay, so this is how I did the circuit, and then it's reflection. So then I have assigned I have linked the FEM coil and the circuit. So look at here. When I press 1, it's actually inwards sign, and then here's an outward sign. When downward sign and upward sign. So it's both linked, basically linked. So same goes to the other one too. So it's all linked. So when I've done both of this, I go to the final part of my process, my activity, which is the mesh process. So how did I do this? Let me regenerate this first. Wait, not regenerate. Let me show how did I do the mesh for this. So I press part. So I have to, if I want to mesh the whole motor, you have to select everything. So you see, you can see all our compartments here, 4 amateur coils, 1 stator, 2 magnets, and 1 rotor. But you also can choose separately, like for instance, like, okay, let's say this. I say 1 permanent magnet is highlighted. Oh, you want 2 means 2 permanent magnets with 1 rotor is highlighted. So, but we don't want that. What we want is to mesh the whole compartment here. Here, see, all 8 is chosen. So once we have done the meshing process, we have to go and do some settings at the mesh, where we have to choose the slide mesh, which is written at the second option here, and then we have to press the button generate or regenerate. So for now, for me, choose regenerate. So now currently it's regenerating the mesh. So just hold up for a bit. Okay, so now the image is regenerated. Okay, now we have to run our photo. So before that, we have to check our properties. We have to amend all of this, which is our steps is 37, our n times 0.05, our duration is 36, and also our conversion. Our stack line has to be 25 constant. Okay, so that's all. So now I have to right click here and run activities. So yeah. So now the JMac designer is currently running, checking whether if there's any mistakes or not. So it's currently running. Okay, yep. I guess it's done. I think there's no errors. Yeah, it's good. So now I can have a look at my results. So the results is actually quite simple. You can get it from the, you right click on your graph. So you can get a lot of results for you. So let's look at the torque. So this is the torque graph, the torque against time graph. You can also have a look at the coil flux linkage, which I have attached in my lab report. So this is where I got the graph from. And yeah, so that's all from me. Thank you.
Assalamualaikum and a very good morning. My name is Nushafiqah Binti Rosli. My metric number is DE210032. I'm going to explain about activity number 3. The first thing we need to do is to extend the 2D model to 3D model, which is we need to right click the at here 2D model, and then we click the extend model to the 3D. Okay, and then we click OK. After we click, we are going to get the result here. As you can see, it gives us the 3D model. Okay, After we do that, we need to do the step number 2, which is set the condition setting. Which is first thing we need to do is to click condition and then click symmetry boundary, and then after click the symmetry boundary we need to know which one is the top and which one is the bottom. So to know that, we need to click front. So for front it's going to be the top and the back is going to be the bottom. So for top we have to choose the upper coil, so we take the symmetry boundary and put it at the upper coil. Here one, and then we click another one, symmetry one. Here another one. Okay, and then for the bottom we need to choose all of it, exclude the upper coil, which is symmetry boundary here, then here, and then here, and then here, and then here, and then here. So we click OK. After we do the symmetry boundary, we need to set the mesh properties on the project manager toolbar. So we choose mesh and we choose the properties, and then we need to choose light mesh, and then when we choose the slide mesh, we need to do the model length, which is 1.05, and then we go to the slide division. We choose the set circumferential division automation and then click OK. After that, I'm going to create the mesh, which is we need to right click at the mesh and then we add size control and then part. So we need to choose the rotor pipe here, here, and here. Then we click OK. And then we have to take another one. We need to do another mesh, then access control part, and then we are going to do the stator pipe. So for stator pipe we need to choose all of the armature coil. Then after we choose armature coil, we need to choose the stator. Okay, then we click OK. After that we need to set the rotational mesh, so mesh, and then we choose the rotational period mesh, and then we choose automatic. Okay, and then we click OK. After that, we need to generate the mesh. So we right click the mesh and then we regenerate. Okay. After we generate the mesh, we need to set the magnetic study and properties, which is we go to the study kit, and then we go to the properties and we set the regular interval 0.05 for end time at division is 36, and then we click OK. After that, we run active case at the study. Okay, after we run the value, we can check the result by here, graph, and then we click at the top, show. And as you can see, this is the result for the top. So that's all from me. Thank you.